We now will do arithmetic with polynomials. And technically, you can add, subtract, multiply, or divide polynomials, but when you divide polynomials, it may produce something that is no longer a polynomial. We want to only get new polynomials from our arithmetic, so we are only going to be dealing with adding, subtracting, and multiplying polynomials. And you're going to see that adding and subtracting polynomials is actually quite easy given what we've already talked about with the distributive property and combining like terms. So let's find the sum and the difference of the polynomials 3x squared minus 11x plus 2 and negative 5x squared plus x minus 4. So we'll do the sum first. We've got the polynomial 3x squared minus 11x plus 2, and we want to add to that the polynomial negative 5x squared plus x minus 4. Well, this is a matter of just combining like terms. There's nothing to distribute in here into the back or out in the front here either. So these parentheses don't even matter. This is really just 3x squared minus 11x plus 2 plus negative 5x squared, or you could write just minus 5x squared, plus x minus 4. Combining like terms, 3x squared minus 5x squared gives us a total of negative 2x squared. We've got negative 11x plus 1x would give us a total of minus 10x. And we got 2 minus 4 gives us a total of minus 2. The sum of this polynomial with this polynomial is negative 2x squared minus 10x minus 2. Let's now do the same thing, but look at the difference instead of the sum. So we'll have 3x squared minus 11x plus 2. We want to subtract from that negative 5x squared plus x minus 4. Now in this case, we can't simply just ignore these parentheses and combine like terms. There is nothing to distribute in here, so we can ignore them in the front. However, we want to subtract this whole polynomial. So subtracting this, again, we talked about this earlier, is like adding on negative 1 times that. So it's like we're distributing a negative 1 into each of these three terms in the back polynomial. And if you do that, negative 1 times negative 5x squared is plus 5x squared. Negative 1 times x is negative 1x, so minus x. And then negative 1 times 4 is negative 4, but you're subtracting that, so it's the same thing as adding 4. Once we're here, we're going to combine the like terms. 3x squared plus 5x squared gives us a total of 8x squared. Minus 11x minus another 1x is the same thing as minus 12x. And plus 2 plus an additional 4 is the same thing as adding on 6. This expression is the difference of these two polynomials. So we technically already had the skills for adding and subtracting polynomials, but now we want to look at multiplying polynomials, and this is something new. To multiply polynomials, it's a matter of taking each term in the first polynomial and multiplying it with each term in the second polynomial. This could be extrapolated to more than two polynomials, but we're going to look at just the product of two polynomials. So each term in the first polynomial multiplies with each term in the second polynomial. So polynomial multiplication is really a function of the distributive property. You're essentially doing several distributions. You're distributing the x plus 3 into the x plus 2, but without getting into all the details of exactly how you're doing all that distributing, technically the way to think about it is just multiply each term in the front with each term in the back polynomial. So the x is going to multiply with the x back here and with the 2 back here. X times x is x squared, x times the 2 is plus 2x. And then the term 3 in the front is also going to multiply with each term in the back. So we have 3 times x, and we have the 3 times the 2. So we have plus 3x plus 3 times the 2 is 6. And notice these are all additions here because it was addition in both spots here. And once we've done this multiplication, we can now combine the like terms here to simplify this. We get x squared plus 5x plus 6. This polynomial is equivalent to the product of the polynomial x plus 3 and the polynomial x plus 2. Let's try another one. We've got the polynomial 2x minus 7 times the polynomial x plus 4. Each term in the front multiplies with each term in the back. Now, to avoid sign errors or confusion, I suggest converting this subtraction to addition first. So remember, minus 7 is the same thing as plus negative 7. So we're distributing 2x into the x and the 4, and we're going to distribute the negative 7 into the x and the 4. And because it's all addition now, we'll be adding all those terms that we get. So we've got 2x times x is 2x squared. 2x times 4 is 8x, plus negative 7 times x is negative 7x, plus negative 7 times 4 is negative 28. And again, we can combine the like terms. 8x and negative 7x combine to 1x, and we're left with 2x squared plus 1x, or plus x, which is the same thing, plus negative 28, which many people will often write as minus 28. This polynomial is the product of these two polynomials. Let's do it again here. Notice there's a trinomial here. It doesn't matter. You still multiply each term in the front polynomial with each term in the back polynomial. So we've got x times the 3x squared gives us 3x cubed. The x times the 7x gives us plus 7x squared. The x times the minus 1 gives us minus 1x. And then the 1 in the front here needs to multiply with each one in the back. 1 times 3x squared is plus 3x squared. 1 times the 7x is plus 7x. And then 1 times the minus 1 is minus 1. And again, we need to combine the like terms here. We've got 3x cubed. 7x squared plus 3x squared is plus 10x squared. Minus x plus 7x is equivalent to plus 6x. And then minus 1 is simply minus 1 here. This expression is equivalent to the product of these two polynomials. And now we have this last example. Some people will look at this and say, wait a minute, it's not of this form. It's not the product of two polynomials. And they automatically think, oh, I can use the exponent laws here where I'd square the n and square the 8. That actually is not correct whatsoever. Remember, the exponent laws apply only to products and quotients. This is a sum here in parentheses. So you cannot raise the n to the 2 and the 8 to the 2. Instead, you need to realize that this is actually one of these in disguise. Remember, squaring means you've got two of those things multiplied. So this is n plus 8 times, again, n plus 8. Now, if you look at this, which is equivalent to that, this looks just like these problems. So you need to realize that this needs to be rewritten like this. You cannot apply exponent laws to simplify this. Now that we've got it written like this, we're going to multiply each term in the front polynomial with each term in the back polynomial. The n times the n is n squared. The n times the 8 is 8n. The 8 times the n is 8n. And the 8 times the 8 is 64. And again, if we combine like terms, we get n squared plus 16n plus 64. This is the square of the sum of n and 8. Again, it's one of these types of problems, just in disguise.